Hello, hello. I'm so happy today to have a conversation with Lars Sandberg, the CEO of Blue Ocean Closures. And Lars, I think the challenge is that most people don't realize how complicated closures are. They may be this little thing, but they create havoc. So I'm so happy to have you on the show and excited to have this conversation and learn much more. So thank you so much for agreeing to be with us today.
That's brilliant, Ved. I'm so happy that we can be there and so happy to represent Blue Ocean Closures and certainly talk about closures. I didn't know much either a couple of years ago, but I'm becoming somewhat of an expert, I think.
Superb. You, of course, come from the land of cellulose. So I'm going to start with your growing up influences, as we see that you've had a few years of experience. So tell me about your growing up years and were there early influences in regards to either cellulose or ecology. How did it shape you? Your growing up in Sweden.
Now, you know, I grew up in the northern part of Sweden, or actually the middle part of Sweden, but considered the far north. A lot of forest industry, very simple life, very homogeneous society when growing up, very simple, spending most of the time outdoors, running in the forest or jumping ice flakes or whatever you would say. And it was a simple time to grow up. Probably the most dangerous things there was to fall off a cliff or fall into cold water or something like that. So very stable. Nature always there. It was a time when was a lot of focus on non-littering, non-smoking, non-nuclear. So I think that rather the time that kind of that shaped you in that way. Very simple, very straightforward.
I, of course, was mentioning to you shortly before we started recording that Sweden has been such a big part of my life, and so has actually KTH. And we've done a lot of work with Inventia and then Rise, and that whole cohort. A very dear friend of mine, Bruce Lynn. I don't know if you know him from KTH. Again, we've spent a lot of time together. So I want to learn more about why you chose KTH and why mechanical engineering. How did that come about?
Yeah, so I did well in school, and there was no plan to study, go to university. But after working a while, you kind of realized that there were benefits of having an education, and we had the opportunity to go to the Royal Institute. My to-be wife and I, we wanted to go a place where we both could find a good education, and the KTH, the Royal Institute of Technology in Sweden, is just a brilliant place to do that. Didn't meet Bruce Line at the time, but I actually know him from later. The Cellulose and Pulp and Paper Society in Sweden is quite small, so I actually been traveling and sailing with him in the Caribbean in Belize. So he's a great guy, but that probably tells you more about the small society where we live there. But I think talking about sailing in Belize, also might know that Bruce is a keen diver, and I also spent a lot of time diving early in the waters, free diving, and then scuba diving, and then instructor, and then instructor, two instructors, and moving on doing my military service as a EOD diver and so on. So I think that links a lot also to what you asked before, kind of sustainability in nature and being a part of that. Just being underwater, seeing it as it is, creates a connection. I don't know if you agree, but it certainly does. Yeah.
Oh, for sure. I think the oceans give you so much. I've definitely not been free diving, but I've been diving as well. In fact, what came to my mind was that I went to university in London, and some of my closest friends, even till now, were Scandinavians, and one of them was a wonderful guy who, again, is still a very dear friend, a guy called Håkan Enochson, and he exposed me. And he again went to the Navy side, and he was an amazing swimmer, Lars. And I kind of learned so much from him because we would come go swimming together, and it was just amazing to kind of swim with him and spend time with him. And then he came and worked with us in India for a while, and it's been a very close relationship. And he had a pulpwood forest in Usbi. So we went and spent one New Year's there, and so we've done a bunch of things. So of course, so choosing mechanical engineering, I want to know a little more about that, and then of course immediately getting into the pulp and paper industry, and
Yeah.
that whole journey would be great to know how that transpired.
No, I mean, I think what you study shapes you a bit. I studied mechanical engineering with a focus on the paper and pulp industry. I also took some classes in chemical engineering, and I think that those two perspectives helps you give a full picture of things. Something is chemistry, something is mechanics, and sometimes those two things goes together, and which is quite often the case in the pulp and paper industry. So it was a great time, great people to study with and study for. It was a time when the paper industry and the processes in the paper industry were still quite developing, and I had great teachers in that way, both for paper mechanics and for the processes. So a really good ground, and it also helped me to find a good job in starting in the paper industry, actually coming to what was then a company called Stora that became Stora Enso. And yeah, super nice way to start being able to explore a lot when it comes to mechanics and creeps and how fibers interact and how they don't interact and so on. So I love it. It's pretty nerdy, I know that, but I'm so amazed with these small fibers and what you can do with them.
I agree with you. I again came into the industry a while back, and one of the people who really influenced me early on was an expert in non-wood fibers, which is our background. And you would relate to this by your last statement. And what he taught me was everything is common sense. You have to think of yourself like the fiber. When you think like the fiber, then you can, imagine what will happen when it's put through a slot or or refined in a certain way, etc., etc. And then you can imagine yourself, and that's really helped me. But Lars, I'm curious about doing mechanical engineering and then getting into R&D and innovation. What was the How did that happen? Because typically we expect mechanical engineers to be the ones who are keeping the machines in good order. So so why was that side of you kind of enhanced and picked up by the company?
I think, as many things in life, partly coincidental. I lived in the old town of Stockholm, and there was a job opening in the small town of Säffle. I have to look it up on the maps, trying to find it. Basically, we traveled there. Both I and my wife was offered good jobs at that research site. I think the reason why they were looking specifically for a mechanical engineer at that time was that the industry came a little bit closer at that time to start looking at the products, not only the processes. And part of that was working with finite element calculations, which was something that I had the opportunity to study at the Royal Institute. So it was a good start in that way to come in and shift the focus a little bit from the mechanics of the production to the mechanics of the products. And that is also why I've always been kind of very much fascinated by packaging. Packaging is mechanics, it is a process, it is cost, it is sales, it's commercial, it's a lot of things embedded in the same body. Love it actually. It's so it was very lucky to have a good start there with Stora at that time.
And then, of course, you go into a bunch of very interesting structures, I would say, with Tetra Pak. And then, there are a couple of areas which I did not understand so much: the dough tank and the throw experience. What was happening there from your resume? So I would love to know that journey before we jump into the current undertaking.
No, I think I've always been interested in seeing things come true. And when you do research and you do development projects in big companies, you after a while you realize that there is more than the technology and the economy that is driving things. It's the politics, but it's also how it's what projects you choose to work with and how it's accepted by the end users and the customers and the sales part of it. And I became very fascinated through some friends towards how users interact in when you are starting something, how users innovate. And we went almost religious on that side and started a company and worked with users as support for innovation. So very close to industrial design and industrial design processes. How do you include input from others, but also user innovation in the name of Eric von Hippel, a US researcher that is kind of brought that forward, basically saying that most new things comes from users. The lung and heart machine was not invented by a company building lung and heart machines, obviously, because there were none. It was invented by a doctor who needed that. You were based in Oregon. The mountain bikes, they were not invented by a bicycle company. They were invented by guys wanted to ride down the mountain in high speeds, putting motorcycle brakes on their bikes and so on. So I was fascinated by that, still am fascinated about that. And I think that is the dual side of innovation. You need to have the technology, you need to have the economics, but you also need to have the heart and the soul of things, the need to bring things forward. So that was, so we put almost 8 years on that, working in a small consultancy, basically working with users and user innovation. So away from the industry for a while, but I think a good part of my journey and my learnings simply. So that's brilliant.
And when you say users, it's actually in a way the customers, because they are the ones who are going to use the product that we make, right?
Yeah, the ones that has the need, but it can also be in B2B. You have someone running a machine and making improvements of that machine, not because he wants to sell the machines, but because he wants to run his process more or better or more efficient or something like that. So it's everywhere. It's nothing magical about it. It's, I think you and I are probably good examples also improving things in our daily life, that not to sell it, but to have a better life or every day in that way. So it's more that aspect of it. But for sure, people becoming the customer of that product in the end.
And then, of course, like you said, you come back to the industry, and it is Billerud, which is, of course, a very innovative company. Would love to hear more about your experience there, and of course, that transpired into what you do now. So, that whole part of your journey, how did that shape up?
Yeah, I actually had a short while in North America, which was very rewarding. I spent time up in Vancouver with FP Innovations, so the Canadian Packaging and Forest Products Institute. Lovely. It's you're happy to be in a very beautiful part of the world when spending time in the Pacific Northwest. So, but also good learning, seeing the differences and the strength of the Scandinavian paper industry with its innovation and also kind of high pressure when it comes to sustainability, and see how that drives things. So it was a very natural step to come back to the industry and start working with Billerud Korsnäs at that time, a company that has set out some, how do you say it, moon landing projects, creating a bottle. We were doing battery materials and things that were quite innovative and novel for the forest industry at that time.
And of course, the bottle has been in discussion for a long, long time, and there's all kinds of challenges. And that, from a fiber perspective, I always feel that, is it really better to go the fiber route, or is glass better? Because of the barriers, right? So
Yeah.
so the current many of the bottles right now would end up having a polyethylene lining, or they're trying to do a bag inside or something like that. So how did that whole journey, for you guys to create the bottle, transpire? Because I'm sure these were things going on in your mind as well.
Yeah, no, absolutely, and I think it's a very sound thing to question it. I came in while in the project and had the opportunity to work with the barrier and looking at both feasibility and the possibility to move forward from a cost perspective. And as you know, there are many companies working with bottles. We had this company Paboco, and I think that they are very far ahead when it comes to this. And as one of our customers now, the Absolut company are phrasing it. I don't think that it's from their perspective so much of having just one solution. It's more looking at differentiation, the possibility to pack the right product in the right package and so on. And paper definitely plays a role there. We will see how big it's going to be. It's going to be much bigger than it is now. You see that the processes from several companies are not anymore experimental. It's becoming production equipment. You're right. It's probably going to be combinations of polymers and fibers for a long time, but so is the beverage cartons and a very successful way of lowering carbon footprint, for example. So yeah, I see it as positive. We will talk about closures soon, and for us, we are not making the closures for paper bottles. We are making the closures for metal, for glass, for plastic. So it's in one way a much easier task to go on in that way, and easier to create a solution that can be used by many and for many different products in that way.
You just said something that intrigued me in terms of the kind of the fiber board based Tetra Pak kind of material, and you said it's a lower carbon footprint. So how does that educate me on that? Because mainly because of the perspective of multi-layered, and then that makes it difficult to downcycle, or of course composting is impossible. So how does that make it better? Is it an overall kind of life cycle analysis because of the mining and everything else that goes into the other substrates? How does that work?
So fibers give a lot of stiffness, and you need stiffness for packaging. So you need a material, and the more bio-based material you can use, the better it is from a carbon footprint point of view, obviously. Recycling, I think that the Tetra Paks of the world has a little bit unfair, being treated as hard to recycle. In Scandinavia, we have some recycling mills, and they actually regard the fibers from Tetra Paks very, very highly. They are clean because they are protected by polymer layers. The polymer layers goes away in the pulping process. You get clean, fresh, strong fibers out of it, and obviously you get some react from the plastics, but that is used for energy. And as you know, very little of the polymers used for packaging is actually recycled in a way. So in this way, you will actually get a big portion of the package actually recycled instead. It depends on where you are in the world, how it's sorted and how it's recycled, if it's going to be downcycled or as in Scandinavia, recycled back to packaging. But still, lower carbon footprint, less plastic that goes into the nature if it's treated in the wrong way. But I think I'm also part of the things. Growing up in the paper industry, growing up in Scandinavia, it's very easy to understand and see the benefits of the fiber-based products. Of course, I'm part of this in many ways. But just looking at the facts, like just looking at the actual carbon footprint from life cycle analysis, you will see the benefit, at least in that side.
Oh, good to know. I always kind of I'm not very clear about like whether it is better or worse. So it's good to know that there is a lower carbon footprint in aseptic kind of packaging. Okay, let's jump into the why we are here. Let's talk about how you decided that closures is going to be your life. That's a very, very specific area of interest. And of course, let's jump into that first, and then get into the intricacies of how you created it.
Yeah, brilliant. So there was actually, I need to start from a technology point of view, and it was a technology basically rediscovered in Scandinavia in the early 2010. Came from the university. It also came from Danish companies starting to basically mold dry fibers together. That was picked up by companies like Södra, which is a major forest company in Sweden, and smaller companies like SWT, Swedish Winding Technologies, and basically looked upon and refined. And Swedish Winding Technology were spun out, became what is now Loop Factory and Youngie. So a path still towards the way of commercializing dry molded fibers. And there was a parallel path also that ended up in being a company called Pulpac. We followed this early. I had the opportunity to look at the technology already in 2015. Uh, we were looking at it from different perspectives, and we wanted to see if we could improve the delivery model, basically making it more efficient. Seeing the challenges of integrating all of these processes into one machine, we wanted to see if we could separate them, and we looked at that in different ways, separating the fiber treatment or separating the pre making of a mat or whatever. And we came to the conclusion, basically going back to standard technologies using air-laid materials. So the same type of materials that you use for high-end paper tablecloths or hygiene products, and that has been formed into 3D shapes for a long time. But basically going back to that and including some of the new learnings. And we saw, in addition to having a more sturdy and simple process, we also saw that we could do more advanced shapes, basically by adding wet laid materials into this mix and making better mechanical properties of the material that went into the pressing operation. We could also make much more advanced shapes, basically. So that gave us a sweet spot compared to others. We could do something that was very homogeneous, very exact, and very sturdy. And no one was doing, or no one is still doing, closures. So basically, advanced screw caps. We were not sure about it, but we basically started working with it with a very strong philosophy that keep things sturdy, keep the machinery simple, not taking easy ways when it comes to the forming process, but doing things with very stiff and robust tools. And it took us some time, but we realized that we can do something that was actually amazing. And me coming from the paper world, seeing that we can do products that are super stable, or down to 1/10 of a millimeter exact, forming undercuts, forming a lot of different advanced shapes, creating a material with a density of 1.2, which, if you compare it to normal cotton board, which is maybe 0.7, 0.8, we actually create a totally new material. It's still the same paper fibers, but compressed so dense that there are almost no air in between them. We're creating a material that has a very, very high modulus, very high compressive strength, and it's just amazing. I'm totally amazed. If you asked me a couple of years ago, I would say, nah, that's not possible. So it's feels like a big stroke of luck to be able to find and being part of pioneering this technology, creating this new material. So it's, as you can hear, I'm still amazed with what we can do. In short, so.
But Lars, it's a very narrow area of focus. When you look at a size of a bottle and you look at the size of a cap, what is it that makes you focus so much that, I'm going to solve this one challenge rather than saying you could have done both, right? Both can be done in dry molding. I can do the bottle and the cap, but you chose the cap. So I'm
Yeah.
sure there's thinking behind that. And of course, I understand the complexity of it, but why not provide the buyer or the user with the entire structure?
So I didn't want to upset my old friends in Paboco and doing better bottles than them. So, but no, joking aside, I think one of the things that has been fundamental for our success is to be able to focus. I mean, if we would starting doing everything that people asked if we can do, we would have been totally spread out. So this focus on one product is really, really interesting. And I think also turning it around, as we are not bringing a new technology to market as many others do, we are bringing new products to market. We immediately get interesting for brands. And we have had great collaborations with companies like the Absolut company, which is part of Pernod Ricard, with Coca-Cola, with L'Oreal, with the biggest dairy companies in the world, and so on. And coming out with the technology, or just the technology, we would not have been able to do that. Also, there are some advantages when going to market with closures compared to bottles. I know that you have been talking a lot about barriers in previous podcasts, and the complexity. I know the complexity to make barriers of keeping water molecules or oxygen molecules out of paper is really, really hard. In this way, we can use existing technologies. We can add polymer top seal liner exactly as it's done in metal closures or in other closures, and we can just use the mechanical properties of the fibers basically to achieve this. So it's not cheating, but it's choosing a path where we can find some products that can come quickly to market. And in just 2.5 years, we had the first products out on the shelf, actually. So I think that's quite impressive. And you might think that it's small things. I totally agree. But if going back to the beverage cartons, there are some, if I remember right, 135 billion beverage cartons with plastic closures produced every year. That's some 150,000 tons of material and a value of many billion of euros. So it's not a small area in that way. Actually, the world of closures are quite interesting and quite big. I'm not saying that we're going to stay there only for all future, but it's not a bad way to focus from the start and to bring a product to market instead of trying to bring a technology to market.
That's very interesting to hear because, yes, I'm glad you used the word tons because I think as paper makers, we can't think, below tons. So I'm glad that there is enough tonnage available even in this one segment. And of course, you only talked about aseptic packaging. There'll be many, many more uh, different products that you can utilize it in. So uh, is there a reason that you decided that you're only going to stay with cellulose, and was that just because of the background with dry molding, or was there another reason as well why you felt cellulose is the right material and I'm not going to experiment with anything beyond that?
No, there's actually a very simple solution, a simple reason for that, and that is recyclability. So you know that there's been a lot of development in the forest industry the last 10, 15 years about breaking down fibers into smaller parts, using the lignin, using the microfibrillated cellulose, and so on. So but that is obviously you're using a lot of energy to break it down, and you lose the I think most important property of these fibers, that they are recyclable. I'm totally intrigued about them. They are like Lego blocks. You can build something, take it apart, build it again, take it apart. So it's a brilliant way of using a material. So, and the other aspect of it is that they are abundant. There are some 100 million tons of pulp produced every year, and you have a background in non-wood pulp, so it's even more coming onto the market there. We see even more eucalyptus forests being created, actually not deforestation but forestation in South America. So volumes are there. So if you want to do something that has a big impact, I think going with cellulose is the right way, and keeping the fibers as they are is definitely the right way. So that's our thinking. I'm totally aware of that others can have other thinkings, but that has been our thinking in this.
And it's also the background, I guess. You understand the cellulose fiber
Yes.
way more than you would understand a PLA or something like that. I presume, like I'm sure you understand those materials too. But I
Yeah.
guess with so many years of experience, it's obvious that you might have an affinity at least to cellulose. So talk to us more from a perspective of the closures and the complexity and the challenge. Why is it that they are so difficult? And of course, like tell us more on a layman level that why is it that closures are more difficult than the bottle sometimes? And I've seen that happen with papered bottles a lot as well. And of course, screwing it in the right way, etc., etc. But yeah, let's start with the idea of why is the structure so difficult, and then what are the challenges that you faced in order to create what you created?
So I think you can break it down in some aspects. One is the accuracy. If you're wanting to do something that where you have threads that is maybe a millimeter high that should interact with other threads that are a millimeter high. You need to be on the 10th of a millimeter scale to actually make something that works. So definitely you need to create something that is stable, and you need to create something that is very exact. And with our technology, we are really lucky. We do not have any shrinkage. The way that we put the fibers together, we are not obviously drying them because we are never putting any water to them. That means that we are creating something that is really stable. We don't have the shrinkage, and therefore don't have the tendency of paper fibers to move with different moisture levels as you would have. The other is probably strength. You need to have something that is strong enough so that you create high enough torque and therefore a good enough seal. And paper fibers are stiff, they are strong, and you also know that cellulose in itself are not so sensitive for temperature. If you go for the most common material used for plastic closures are polypropylene, and then you end up with quite poor properties when it gets cold because of getting brittle, and quite poor properties when it gets warm because of softening, basically. So we are lucky that paper fibers and cellulose are very homogeneous and strong in these fields. This means that we can today, I don't know if it's a good layman's word, but over torque, meaning that we can do something that is harder to destroy when you're closing the bottle too hard than you can do with a plastic closure today. That is only us beginning. I'm sure that we're going to reach even further when we come further down the lane in our technology development. So it actually has a better fit to paper fibers than you would think, but you're absolutely right that it's complex. And the other aspect of it is that we have been lucky. We were early funded or partly funded by a company called Alpla, one of the leaders in the plastic bottles and closures technology. And I think they are one of all of these companies that comes from the plastic side, has been innovative and realizing that fibers are a good way to be innovative in the future. So being part of development of paper bottles, being a very good supporter and part owner of our company. And of course, we are learning a lot. We are learning test methods. We are learning the needs from the market, and we are. Just the fact that I can go to my chairman from Alpla and say, okay, we think that this is good enough, and he agrees is a good thing. Tell you the truth, it was not always like that. The first year, I was super happy. He was not as impressed for sure, but yeah, definitely. So having those two things, and that also put us in a really good competitive situation, because there are not many who have knowledge about closures and has knowledge about fibers. So it's not so easy to duplicate what we have done in this way.
And when you look at fibers, you and I both know a fiber is not a fiber. There's so many differences, even between, say, a northern pine versus a southern pine versus a spruce, a black spruce versus a white spruce, and the cell wall thickness, and then of course I'm not even going to get into different non-woods. And of course the hardwoods have their own intricacies. So is there, in your experimentation, is there an affinity that you have to certain kinds of fibers that work better, and why is that?
To be quite honest, no. We are using the types of fibers we are using is because they are delivered in a way that is good for our system, basically. But we have worked with a lot of different fibers, and we see that we can use them, a lot of different types of fibers. That includes also non-wood fibers, even fibers coming from the ocean. And I think the simple thing is that if you want to do something out of fibers in a wet format, you need to pre-treat them, and you may need to make them soft enough to form a network, and you need to create a surface that is kind of bringing them together. If you're doing like us, just using literally tens of thousands of bars of pressure, putting them together, if you push something together hard enough, it sticks. Basically, we've tested rice fibers, we tested different types of non-wood fibers. We are using long fibers from Scandinavia today, but short fibers are definitely a good possible use. So it's surprisingly forgiving if you come from the normal paper world when it comes to different types of fibers in that way. It's maybe cheating a little bit, just pushing them together using more force if it doesn't work. But honestly, it's not a bad way.
So I know very, very little about dry molding, and the little exposure I have, one of the challenges I'm always told is the degree, the angle, because each time you're pressing a thick sheet, you're kind of creating that force by which, you're also pulling in a lot of fiber in a certain area, especially in a closure. It is almost at or probably at a right angle. So of course you pull in the sheet in a certain way. So how do you tackle something like that? Talk to us a little more about the technology as much as you're able to share, and then the kind of challenges. This is one challenge that immediately comes to my mind, more again from a very layman perspective. But the kind of challenges that were there in order to evolve that to be able to produce at least at a decent scale of operations.
No, I think it comes back to what you said about fibers early, that you create some kind of mental understanding about these fibers. You know the length of them, you know the width of them. They are not like tenth of millimeters. They are 1 or 2 millimeters or 3 millimeters or something like that. They are not like millimeter thick. They are very high ratio between width and you get a feeling for how these could move. And part of our key technology, also part of our key IPR structure, is being able to create undercuts and being able to create straight walls. And we are not doing that by directing forces from the outside. We are doing that in the way that we create the molds, basically. So I cannot go into the absolute details of that, but we have been very much focused on keeping everything sturdy, meaning that we use two stiff molds brought together, and we create the forces between the fibers basically in a different way, not just the angle that comes from above, but creating forces in between these walls that are super high. And you should not think about it as force from one side. You need forces from all sides because you want the fibers to stick together in all different directions, basically. So it's in one way super complex. You need to know what you're doing very much when you're designing the molds, and that is part of our core knowledge. But in one way also quite sturdy and simple. It's you have people traveling from all over the world coming visiting our factory, and I'm almost a little bit apologetic when showing them the machine. It's a web, and it goes to dunk, and out comes a closure, and they travel like literally for days to see that. So, but most agree that boring is good. Boring means simplicity, and boring is good in that way.
No, that is so true. Yeah, but I'm sure it is in its engineering, it has to be complex to make it simple in order to get it right. And I can imagine, and you kind of said it in your own way, that there's force from all directions. Because again, on a very basic level, the challenge is always when you're feeding a sheet and the structure has to be a little deep at least. So you're pushing pressure, on different sides, and then that automatically creates a certain stretch for the sheet itself. So you're being able to tackle that shows that there has been a certain application of understanding and engineering to be able to get it right and to produce. To produce it in a lab scale is much easier, but when you're trying to do it at thousands of closures, that's a very different system, especially if you're feeding a singular raw material. So kudos to you to be able to create that and break through and to be able to do it. When you look at the substrate of the bottle, does it matter at all whether the bottle is made of paper, glass, metal, or it's totally it doesn't matter to you what the bottle is made of? It's just it's just the closures will fit into anything that you want it to.
Yeah, so we can reach the same dimensional stability and the same exactness as you would do in a plastic closure. So in that way, it's not a big difference. We can work with glass, we can work with plastic, we can work with metal, and obviously also paper. I think by definition, paper is the most difficult ones. Normally, our structures are stiffer than and stronger than the others for some applications. There are bottles now that we can combine. So our standard closure goes on Paboco's bottle for supplements, for example, and I think that is one of the first. But that also means a lot of development from their side to achieve their part of the equation, basically. And I think dependent on how you make the bottle, if it's done in injection molding, as most bottles or tops are done, then you create something that is quite exact also on the plastic side. If it's other technologies to create the threads, as it's sometimes in beverage cartons, you get a softer structure and you need to be even more exact for that. But you can see us very much as something that mimic or totally mimics the plastic closures, better mechanical properties, some hydrophobication for protection, and then using the same sealing method as you would done for a plastic closure.
So, what has been the challenges that you faced on the side of the market? Has there been pushback of certain kind because people don't know? And how are you tackling that? Because it's ultimately a new product that is being introduced into the market, and there's usually some resistance that comes. So, has that happened to you?
So we see a big interest. We are going to market in basically two ways. One is with standard products. So we have a number of standard products dedicated towards areas that are rather simple for us. One is supplements, so your minerals and vitamins. It's a big area, it's a growing area, and it's also an area where you combine kind of wellness, and that is often close to sustainability in terms of your minds. It's of course a big step to change something on the consumer package. You're changing something that relates to the brand, and the selling in time to do that is quite long when you compare a company that is just turned 3 years. So that is probably a challenge, that the simple time to shift is longer. But we are absolutely confident. We are having several brands going out. The first products are on the market. In this case, we use the exact same sealing methods as is done for the original plastic bottle. We submit induction seal liner with our closure that is sealed to the bottle exactly in the same way as it's done for the plastic closure. You open that, the seal sits still on the bottle, you remove the seal, and you use the package as normal. So we are not messing in any way with the quality of the product in that way, which makes it easier. But I think that we just need to realize that shifting something on your consumer products take time. We see that it's happening quite quickly now. We are aiming for quite big volumes in the end of this year for these standard products. So that's one side. The other side is bespoke products. So if you have a package, you want to move that forward, move it towards something more sustainable, do it with something that is more interesting for your consumer, then it's a really, really good way of moving forward. And we are developing bespoke closures now for many global brands. That includes really difficult things like alcohol. Vodka is one of the hardest thing to pack just because of its cleanness and taste and odor and things like that, down to dairy products, to spreads, cosmetics. There's a lot of different drinks that are opening up for us, and it's new areas coming. You know that in Europe there's a big trend towards reusable bottles now, and what could be better to combine with a reusable bottle, a super low carbon footprint fiber closure. Of course, that is at least how we see it. So many opportunities opening up and a big interest simply.
And you mentioned some really great large customers like Absolut, and then of course, on the milk side. And so, how's it been dealing with them in terms of receptivity? And do they see a benefit of? Of course, they have to get a certain brand value as well from this. That they're using a fiber closure. So it'll be very interesting to know how has that journey been. And of course, you said on reusability. So I was intrigued by that too, because that means it is reusable. And does that mean that it is going to keep its thread for a significant amount of time in order to be able to be reusable? So two disparate questions, and you can take them as you want.
No, that's brilliant. So the pioneering partners, companies like Coca-Cola, L'Oreal, and Pernod Ricard with Absolut Vodka, has been absolutely brilliant. They honestly want to take a part of create something new. They have a big heart. They want to move things in a positive ways, and there is not so many opportunities to do that. So they actually not they have invested a lot in their developments, not in the company, but in their developments, and that has been a very big help in early revenues for us. And their investment is in money, but it's also in time and steering and knowledge and testing and whatnot. So they have been fundamental. They are honestly the real heroes in this way. They are, without them, this journey would not have been possible in the same way. And I hope that we can create value for them in different ways. We were very careful about being used for greenwashing in the early stage, so we have not allowed them to communicate in too early stages, so that just coming in, do something, and then communicating. But they have stayed with us for a long time. When it comes to your second question, it's two things there. When I talk about reusable water bottles, for example, for the European market, no one thinks that we're going to clean the closure. So even if it's a reusable glass bottle or plastic bottle, the idea is that it will still be a one-time metal or plastic or fiber closure. And there we can offer the by far lowest carbon footprint for these solutions. So it's interesting in that way. And then you see another type of reusability. We work with a great Swedish brand called Great Earth, so a supplements brand, and they are now starting sending out their pills in bags so that you can refill your bottles. So that puts high demands on our, so to say, reusability, or the number of openings that we can do. It's not only the 100 or 50 pills that is going to be used the first time, it's also the second filling and the third filling, and we can show really good results there, as good as for plastics in that way. So it's putting pressure on us, it's putting new demands on us, but we are up there already now, and we're going to just improve with time with this new technology.
Oh, that's for sure impressive, because that's what I was wondering from your first statement, that that means that it can be opened and closed multiple times, and it will keep growing from there. Because I'm sure from a fiber perspective, it will not be as easy as like in general as we think the plastic is, because the rigidity is totally different. So I'm sure there is a lot that goes on there. So I'm going to switch to this company that you've mentioned a few times, and I think it's important in this journey, is Paboco. So what is that partnership like? And I know that they are making the paper bottles, and is there a very clear understanding with them that you're going to do something along with them? And of course, I presume that you had this relationship right from the time of Billerud and that whole journey as well. So it'll be interesting to know how that is going to progress in the time to come.
Yeah. So as we want to create impact in as many ways as possible, it's very natural to support things that relates to other types of fiber packaging. But the relation with Paboco is special. As I used to work with them, there are some personal relationships that are still on, and these are, of course, very important. They're also a very clear relationship. They are now mostly owned by Alpla, so one of our investors. And of course, we want to create as much value for Alpla and therefore as for Paboco as possible. So we see us as a sub-supplier to them. We've been lucky enough that they have adopted their first bottle to market in the same direction as we have, so that one of our standard closures can be used without making a specific one for them. Many brands are looking, as you said, for the whole solution. So developing a fiber bottle with the fiber closure. That is, it's more challenges. It's almost like doing a niche of a niche, doing something new related to something else that is new. So it's important for us that we are not defined by being a closure for fiber bottles. It's totally opposite in that way. We are doing closures for all kind of different products. And it actually makes sense. If you think about it, you always have different materials in the bottle and in the closure. If it's your normal PET bottle, it's a polypropylene or polyethylene cap for that. Your metal and glass is combined, metal and plastic is combined, and you don't think so much about it. So we just see this as one more way that brands can differentiate and create something new, create the experience for their consumers and so on. So it's something that I know pops to mind, that you think that it's natural to have a plastic cap for a plastic bottle, but you forget that there are two totally different polymers, and those two polymers are not possible to combine when you're recycling. So I think it's we hope that it makes sense in that way.
But the good thing is that you can combine a paper bottle and a paper closure and
Yeah,
recycle it. So that's
yeah,
a good
no,
thing,
it's
in
definitely
our
good, but
case.
yeah, don't forget the existing market of beverage
True.
cartons, which
Yeah.
is brilliant, and there we can also help increasing the recyclability of beverage cartons, increasing the yield of fibers coming back, taking 1 gram of plastic out and putting in 1 gram of fibers in there. So helping that equation a little bit also for that area, and then we are talking about hundreds of billions of packages. So it's huge potential. I'm sorry about not going all excited about the paper bottles. I am actually, the combination is brilliant, but we also want to focus on markets that
Yeah,
are
yeah, no,
existing and
absolutely.
where we can grow.
When I look at beverage cartons, typically we also see a male side, which is in plastic. So if I look at the current beverage bottles, it's basically it could be the whole aseptic packaging is of course paper plus, but then the closure is a male of a plastic and then a female going on top. So I presume that you're making the top part of it, but what happens to the bottom part of it? Is that evolving as well?
It is. We are actually doing, for example, paper tubes. We are doing both parts there, but in beverage carton, it's so big systems, and there are so much capacity installed. It makes sense for us to start with the cap. We know that we, from a mechanical point of view, can do also the other part, the spout or the neck, but that will come later when we are developing totally new systems that includes both parts. But we have several possibilities to do straight drop-in solutions today, where we can just replace the existing plastic cap with the fiber cap in existing systems, and that is, of course, the first thing that we go for, and then it will take longer time to develop new systems. But I'm totally convinced in 15 years you will not have any plastic closures on fiber packaging anymore, and that tells you something about the potential for our company and for this field in total.
That's really good to hear. So you've mentioned a few times Alpla, and of course you must have had other funders. And a lot of the listeners for our show are also people who are in the starting up kind of phase. So how easy or difficult has it been for you to get the right funding from the right people, of course? And has that been a difficult experience, or has that been relatively God sent and easier?
So it's the first time I do something like this. As you understand, I'm a company coming from big companies, and I'm a guy coming from big companies, and it's honestly, if I knew how hard it was, I would have done a lot of more training before I started. But we were lucky from the start. Alpla is a forward-looking company. Also, Glattfelter, the other first investor, is a forward-looking company. Our third investor, which is a Swedish pulp company called Rottneros, is also they want to expand their business, not only producing pulp but expand their business. So if you look at it from that side, it's been quite straightforward, but it takes up way too much of my time. Obviously, time that I would like to use for other things. We are just in the process of closing one funding round, and of course it's stressful in that way. But I think it's an interesting way of creating resources to grow sustainable products. You have someone from the outside that are willing to invest in the future in a way that established paper companies would maybe not be able to do. It's if you're Stora Enso, for example, you need to have other focuses where you invest your money. This can be people coming in with money from the outside in a different way. So it takes a lot of time. I've learned so much during this period. I know much more about startup funding now than I did obviously 3 years ago, but it takes a lot of time. It has been relatively easy, even if startup funding has been soaring now for a couple of years. It was a top in 2021 or something like that, and really tough after that. But we've been able to sustain our funding in a good way.
What about building a team and culture? How easy or difficult has that part been?
Oh, that's the brilliant part, actually. I'm sure that you have also built teams, and so lucky to have it. We are 24 here in the team. People from different parts of the world, people that has come up to Scandinavia to work with us. We are also in a region, the region of Karlstad, just in between Oslo and Stockholm, where a lot of paper and pulp industry was born and was developed. Actually, a lot of non-wood fiber pulp was developed in this region, even if it's not the core from the start. So we are lucky to have good people to recruit, and we've been able to build a team, put a lot of effort on their technical skills, not only their social skills, but created something that is a very warm and welcoming company. And that goes for everything from our research operators, who are absolutely brilliant, to our experts and IPR experts and material experts and project managers. So we have been lucky in that way. Actually, we have not failed in any recruitments, which is, I think, quite worth noticing. And I think part of that is that we have a heart somewhere. People want to work for something that is creating value, creating something new, creating something sustainable. So it's been good, and we hope to grow carefully also going forward, simply.
It's good to hear, because that's definitely a big part of any entrepreneur's journey, to find the right people to be with you, to be able to kind of do what you're trying to do, because you need so many different talents, and it's good to hear that you've been able to find them. So what about
And to be very, very straightforward there, sorry, it's not my doing. It's very much the rest of the team. To be quite honest, I'm quite unsocial and not the best people person in that way. But if you realize that, you can also surround you with people that have different skills. So that's brilliant.
Yeah, but also as entrepreneurs, sometimes we want to do it all, and we don't really play on our strengths. So realizing that is also a good thing. That okay, let
Yeah.
somebody else do this part of it. So I think that's important too. So what about? I'm going to take this towards my closing questions. So what about the current capacity that you have? And then if you look at the next 4 to 5 years, how are you thinking about, what would be a dream that this is where I want to reach? This is my current capacity, and this is where I want to reach, and how I want to do that. What would those components be?
So we all the time have developed our technology on full-scale production machines. That was part of the philosophy from the start. This means that we have 3 machines installed now, and 2 of them we see them as our production capacity. They are in a certified food safe area. The capacity on these machines they are able to do about half to 1 billion closures. So the capacity on the installed machines are big. And during this year, we are now scaling up through bigger tools for these machines, and scaling up with more shifts for these machines. And when we come to the end of the year, we have reached a significant or a bigger part of that capacity. Then it will be time to start the next location. And we, even if closures travel quite well compared to other packaging products, you would like to produce them quite close to your customers. And that means setting up production in new locations, using our existing production facility as the learnings from that as a model, and then setting up. The concept that we have is built to be able to be scaled in that way. We can install a machine in 4 days. You only need a concrete slab and some electricity, and quite a low amount of electricity to get it up and running. It's not too complex, meaning that you can use operators without too much training. And so we're preparing to scale in that way. Of course, if someone when we are proving the concept want to do something like plant in plant or licensing in a far location or something like that, we are open for that. But we are going to market as a converter in a quite straightforward and boring business model, taking responsibility for setting up the business, basically.
So I presume that you're manufacturing your own machines too, and you kind of mentioned it right now that it could be a different model as well. So would you look at selling machines too, or just looking at converting yourself, or like you mentioned that you may or may not do the franchise kind of model? And the second part of my question is still left. So I want to ask you again that, what will the dream be in the next 5 years?
Yeah. Okay, so coming back to your final question there again, but we are actually not building the machines. We've chosen a different path. We are buying machines that are built to convert sheet metal, so strong, fast machines, and then we are building very specific tools for these machines. So that's also part of keeping the costs down, keeping the sturdiness up, and being able to scale with machines that we can buy from the shelf. For your second question, in a couple of years, we honestly want to grow. So if you go 5 years ahead, we will have at least 6 locations. We will have several machines in each location, and we will be really efficient when it comes to operations. We start as babies learning to walk, as some of our customers said, but we also have the advantage starting from scratch. We do not have any existing systems, IT systems that are clogging things up. We can start building something that is efficient from the start, for example. So we will, with the help of our owners and others, learn to have an operation that is super efficient and grow in that way. So I hope that we can have something set up in India or in Oregon or somewhere else, so that it's easy to pop down and meet us at location, basically.
Superb. That's so good to hear. And to my final question, what does good garbage mean to you?
So I love the title, and I actually had some time to reflect about it. First, questioning, do we fit in? We are not using recycled materials, but obviously good garbage is something that is not hurting people, that can create value in the next step. And coming back to my fibers, they are brilliant in that way. If they end up in nature, they are natural. They are the same fibers as in our trees. They will not hurt you. They will not create microplastics. And you have the great opportunity to use them again and again and again. And as you know, we are recycling maybe 70-80% at least in Scandinavia, and also in other parts of the world. So that is good garbage for me. That is not ending up as microplastics in our ocean, basically.
Thank you, Lars. This has been such a joyous conversation. I know that this is such a specific area that you're tackling, but I know personally, I know the complexity of it. So you make it so simple, and it reminds me of one of my kind of mentors who talked about it being everything in life about being the miss-kiss theory. Make it simple, stupid. Keep it simple, stupid. And I think you espouse it in so many ways. So thank you so much for the work you're doing, and I'm sure that you're going to leave the world a better place for all of us. Thank you so much.
Oh, that's brilliant, and thank you for your time and your efforts, Ved. Totally appreciate it. Appreciate your podcast. So brilliant. Thank you so much.